Decimal time is the representation of the time of day using units which are decimally related. This term is often used specifically to refer to French Revolutionary time, which divided the day into 10 decimal hours, each decimal hour into 100 decimal minutes and each decimal minute into 100 decimal seconds, as opposed to the more familiar Standard Time, which divides the day into 24 hours, each hour into 60 minutes and each minute into 60 seconds. The main advantage of a decimal time system is that, since the base used to divide the time is the same as the one used to represent it, the whole time representation can be handled as a single string. Therefore, it becomes simpler to interpret a timestamp and to perform conversions. For instance, 12300 is 1 decimal hour and 23 decimal minutes, or 1.23 hours, or 123 minutes. 3 hours is 300 minutes or 30,000 seconds. This property also makes it straightforward to represent a timestamp as a fractional day, so that 2015 to 12-31.534 can be interpreted as 5 decimal hours and 34 decimal minutes after the start of that day, or 0.534 of a day through that day. It also adjusts well to digital time representation using epochs, in that the internal time representation can be used directly both for computation and for user-facing display. History. China decimal time was used in China throughout most of its history alongside duodecimal time. The midnight to midnight day was divided both into 12 double hours and also into 10 Shi, 100 Ke by the first millennium BC. Other numbers of Ke per day were used during 3 short periods: 120 Ke from 53 BC, 96 Ke from 507-544 CE, and 108 Ke from 544 to 565. Several of the roughly 50 Chinese calendars also divided each K into 100 fen, although others divided each K into 60 fen. In 1280, the Shushi calendar further subdivided each fen into 100 miao, creating a complete decimal time system of 100 Ke, 100 fen and 100 miao. Chinese decimal time ceased to be used in 1645 when the Shizhan calendar, based on European astronomy and brought to China by the Jesuits, adopted 96 Ke per day alongside 12 double hours, making each Ke exactly 1/4 hour. France. In 1754, Jean-Laurent D'Alembert wrote in the Encyclopédie, "It would be very desirable that all divisions, for example of the livre, the sou, the toys, the day, the hour, etc., would be from tens into tens. This division would result in much easier and more convenient calculations and would be very preferable to the arbitrary division of the livre into 20 sous, of the sou into 12 deniers, of the day into 24 hours, the hour into 60 minutes, etc." In 1788, Claude Boniface Collignon proposed dividing the day into 10 hours or 1,000 minutes, each new hour into 100 minutes, each new minute into 1,000 seconds, and each new second into 1,000 tierces. The distance the twilight zone travels in one such tierce at the equator, which would be 1/1000th of the circumference of the Earth, would be a new unit of length, provisionally called a half handbreadth, equal to 4 modern centimeters. Further, the new tierce would be divided into 1,000 quatierces, which he called microscopic points of time. He also suggested a week of 10 days and dividing the year into 10 solar months. Decimal time was officially introduced during the French Revolution. Jean-Charles de Borda made a proposal for decimal time on November 5, 1792. The National Convention issued a decree on 5 October 1793. She, le jour de minuit est divisé en dix parties, chaque partie en dix heures. Ainsi de suite jusqu'à la plus petite portion commensurable des la durée. She, the day, from midnight to midnight, is divided into 10 parts, each part into 10 others. and so forth until the smallest measurable portion of duration. These parts were named on the 24th of November 1793. The primary divisions were called hours, and they added la centième partie de heure est appelée minute décimale, la centième partie de la minute est appelée seconde décimale. The hundredth part of the hour is called decimal minute, the hundredth part of the minute is called decimal second. Thus, midnight was called either dix heures or 0 heures, noon was called 5 heures, etc. Units were either written out or abbreviated, such as 8h, 72 meters. Sometimes in official records, decimal hours were divided into tenths, or décimes, instead of minutes. Although clocks and watches were produced with faces showing both standard time with numbers chapters 1 to 24 and decimal time with numbers chapters 1 to 10, decimal time never caught on. It was not officially used until the beginning of the Republican Year 3, the 22nd of September 1794. A mandatory use was suspended the 7th of April 1795, in the same law which introduced the original metric system. Thus, although decimal time is sometimes referred to as metric time, the metric system at first had no time unit, and later versions of the metric system used the second, equal to 1/86,400th day, as the metric time unit. In spite of this, decimal time was used in many cities, including Marseille and Toulouse, where a decimal clock with just an hour hand was on the front of the Capitoline for 5 years. On the Palace of the Tuileries in Paris, 2 of the 4 clock faces displayed decimal time until at least 1801. The mathematician and astronomer Pierre-Simon Laplace had a decimal watch made for him, and used decimal time in his work, in the form of fractional days. Because of this, astronomers still use decimal time. Decimal time was part of a larger attempt at decimalization in revolutionary France and was introduced as part of the French Republican calendar, which, in addition to decimally dividing the day, divided the month into 3 decades of 10 days each. This calendar was abolished at the end of 1805. The start of each year was determined according to the day of the autumnal equinox, in relation to true or apparent solar time at the Paris Observatory. Decimal time would also have been reckoned according to apparent solar time, depending on the location it was observed, as was already the practice generally for the setting of clocks. At the International Meridian Conference of 1884, the following resolution was proposed by the French delegation and passed nem. Con. 7. That the conference expresses the hope that the technical studies designed to regulate and extend the application of the decimal system to the division of angular space and of time shall be resumed, so as to permit the extension of this application to all cases in which it presents real advantages. In the 1890s, Joseph Charles François de Raphael, president of the Toulouse Geographical Society, proposed dividing the day into 100 parts, called CEQTS, equal to 14.4 standard minutes, and each divided into 10 dieciséis, 100 centiséis, etc. The Toulouse Chamber of Commerce adopted a resolution supporting his proposal in April 1897. Although widely published, the proposal received little backing. The French made another attempt at the decimalization of time in 1897, when the Commission de Decimalisation de Temps was created by the Bureau des Longitudes, with the mathematician Henri Poincaré as secretary. The Commission adopted a compromise, originally proposed by Henri de Saranton of the Oran Geographical Society, of retaining the 24-hour day, but dividing each hour into 100 decimal minutes, and each minute into 100 seconds. The plan did not gain acceptance and was abandoned in 1900. Switzerland. On 23 October 1998, the Swiss watch company Swatch introduced a decimal time called Internet Time, which divides the day into 1000 decimal minutes, counted from 000999, with at 000 being midnight and at 500 being noon standard time in Switzerland. which is Central European Time. A line painted on Swatch headquarters in the Swiss city of Biel was declared to mark the Biel meridian, and Central European Time was relabeled as Biel Mean Time, even though it does not correspond to actual local mean time in Biel. Conversions. There are exactly 86,400 standard seconds in a standard day, but in the French decimal time system there were 100,000 decimal seconds in the day, so the decimal second was shorter than its counterpart. Accounting. Decimal time is commonly used in accounting for payrolls and hourly billing in the form of decimal hours. Time clocks typically record the time of day in tenths or hundredths of an hour. For instance, 8:30 a.m. would be recorded as 8:50. This is intended to make accounting easier by eliminating the need to convert between minutes and hours. Fractional days. The most common use of decimal time of day is as fractional days used by scientists and computer programmers. Standard 24-hour time is converted into a fractional day simply by dividing the number of hours elapsed since midnight by 24 to make a decimal fraction. Thus, midnight is 0.0 day, noon is 0.5 d, etc., which can be added to any type of date, including Gregorian dates. 2000 January 1.5. 2 line elements. 00015. Julian dates. 2,451,545.0. Excel serial dates. 36,526.5. As many decimal places may be used as required for precision, so 0.5 d equals 0.50000 d. Fractional days are often calculated in UTC or TT, although Julian dates use pre-1925 astronomical date time and Microsoft Excel uses the local time zone of the computer. Using fractional days reduces the number of units in time calculations from 4 to just 1. Fractional days are often used by astronomers to record observations, and were expressed in relation to Paris mean time by the 18th century French mathematician and astronomer Pierre-Simon Laplace, as in these examples. A la distance périhélière égale 1,053,095, ce qui est donné pour l'instant du passage au périhélier, sept 29 j 10,239. Temps moyen comptable manuel de Paris. Les valeurs précédentes de B, H, L, relatives à 3 observations. ONT donné la distance périhélière égale 1,053,650, A pour l'instant du passage. Sept 29 j 04587, ce qui diffère PU des résultats fondés sur 5 observations. Pierre-Simon Laplace, Traité de mécanique céleste. De fractional days have been used by astronomers ever since. For instance, the 19th-century British astronomer John Herschel gave these examples. Between Greenwich noon of the 22d and 23d of March, 1829, the 1828th equinoctial year terminates, and the 1829th commences. This happens at 0d 286,003, or at 6 hours 51 minutes 50 seconds 66 Greenwich Mean Time. For example, at 12 hours 0 minutes 0 seconds Greenwich Mean Time, or 0d 500,000. John Herschel. Outlines of astronomy. Fractional days are commonly used to express epochs of orbital elements. The decimal fraction is usually added to the calendar date or Julian day for natural objects, or to the ordinal date for artificial satellites in 2 line elements. Decimal multiples and fractions of the second. The second is the international system of units, unit of time duration. It is also the standard single unit time representation in many programming languages, most notably C, and part of Unix, POSIX standards used by Linux, Mac OS X, etc. To convert fractional days to fractional seconds, multiply the number by 86,400. Fractional seconds are represented as milliseconds, microseconds or nanoseconds. Absolute times are usually represented relative to the 1st of January 1970, at midnight. Other systems may use a different 0 point. In principle, time spans greater than 1 second are given in units such as kiloseconds, megaseconds, gigaseconds, and so on. Occasionally, these units can be found in technical literature, but traditional units like minutes, hours, days and years are much more common, and are accepted for use with SI. It is possible to specify the time of day as the number of kiloseconds elapsed since midnight. Thus, instead of saying 3:45 p.m., one could say 56.7 kiloseconds. There are exactly 86.4 kiloseconds in one day. However, this nomenclature is rarely used in practice. Scientific decimal time. Scientists often record time as decimals. For example, decimal days divides the day into 10 equal parts, and decimal years divides the year into 10 equal parts. Decimals are easier to plot than both minutes and seconds, which uses the sexagesimal numbering system, hours, months and days, which has irregular month lengths. In astronomy, the so-called Julian day uses decimal days centered on noon. Seconds in a decimal minute. Since there are 60 seconds in a minute, a tenth part represents 60 tenths equals 6 seconds. Minutes in a decimal hour. Since there are 60 minutes in an hour, a tenth part represents 60 tenths equals 6 minutes. Hours in a decimal day. Since there are 24 hours in a day, a tenth part represents 24 tenths equals 2.4 hours. Days and months in a decimal year. Since there are about 365 days in a year, there are about 365 tenths equals 36.5 days in a tenth of a year. Hence the year 2000.5 represents the day the 2nd of July 2000. More exactly, a year is 365.25 days long, so a tenth of a year is 36.525 days. Aviation. For aviation purposes, where it is common to add times in an already complicated environment, time tracking is simplified by recording decimal fractions of hours. So, for instance, if you add 136 and 236 instead of getting 3 to 72 and converting it to 412, you add 1.6 and 2.6 and get 4.2 hours. Other decimal times. Numerous individuals have proposed variations of decimal time, dividing the day into different numbers of units and subunits with different names. Most are based upon fractional days, so that one decimal time format may be easily converted into another, such that all the following are equivalent. 0.500 fractional day, 5 hours 0 minutes French decimal time, at 500.Beats Swatch Internet time, 50.0 Kes or CE 500 millidays. 50.0% time as a percentage, 1200 standard time. Some decimal time proposals are based upon alternate units of metric time. The difference between metric time and decimal time is that metric time defines units for measuring time interval, as measured with a stopwatch, and decimal time defines the time of day, as measured by a clock. Just as standard time uses the metric time unit of the second as its basis, proposed decimal time scales may use alternative metric units.